Okay, it is setting up for the live streaming.
Yeah, looks like it started.
Yeah, so we can start as well. Okay, hello everyone. So, so this is our second session for the problem where we were solving the parsing the MongoDB operations of logs to the generate the equivalent SQL statements, right? And in the first session, we have completed first three stories, that is parsing the insert of log and parsing the update of logs with both the flavors and parsing the delete of logs, where we wrote all these test cases first and then wrote the implementation accordingly. So today we will start we will work on this. We will create this, implement this story 4, which is the create table with the one oplog entry. So this is basically, if you read this story says we need to modify the story 1, where initially in that first story we have generated only the insert statement, right? But that insert statement is not enough, because where is the schema? We didn't create the schema in the Postgres. If we, whatever SQL statement we have generated in our first three stories, those are independent, are okay. But if you run, those are not executable on the Postgres instance because there is no table or table and schema basically, right? So we need to create the schema as well as the table. So that way it will able to insert the record into that table, right? So this story 4 is basically for that, where we need to adjust the story 1 implementation so that it will create the schema and the table. Now, as a part of this story, I'm just writing down what we need to do, right? So, and to just save the time, I'm just copy pasting this statement from the who created the draft. Oh, does that font? Okay. So this is what basically we need to do. We need to generate. So right now, this generate SQL statement, it is returning single string, right? Because it's a single query as of now. But now it should return the slice of string, because this create statement, it should be a create schema and create table. So the data type should be slice of string instead of single array. Then next would be we need to generate that create schema and the create table. Now create, we need to sort the columns as well, which we already did, right? And for each value we need to extract the sorting is required basically for the testing purpose. It is not nothing to do with the executing those statements on the Postgres itself, but it is only for the testing purpose so that we can able to test that code. So these are the things we need to do, so we can go one by one. I'm just again copy pasting this code. So here in case of, again, the oplog is same. We didn't change anything. The only change here is the expected output in the test. So right now it is, so what I'm doing first, I'm just changing the, as part of the story, I'm changing the return type of this as a slice. Now, if I change the, so should I change the type of all these three functions as well, or just create the local variable as a slice, because this these three functions, which is insert, update, and delete, those are not going to return you the multiple values at all. So this insert is just specific for the returning the insert statement. So, and for one oplog, there is no it's written the single query basically, and same is applicable for the update and delete. So instead of changing the signature for all these three, what I will do, I just create the local variable here, say SQLs, which is of string, right? And then okay, I will just return this here. And in case of all these, I just need to append that right here. Okay, so this generate is returning error as well. So yeah, we need to handle that. So again, I am just copy pasting that code to save the time. For that. And if it is not dot. Right, so I need this code for all these three. Again, we can refactor this letter. Right now, I'm just making it work. Just close it. Okay, so we have changed this to slice, and we need to fix the test as well, because in the test we are just expecting the single string here, right? So it should be again slice. Okay. Now it is giving an error that invalid operation, because now it's a slice, so we cannot longer compare this using like this. So we need to use the reflect package for the same. Again, I'm just copy pasting it from here. So the assertion would be like this now. So it will deep equal with the whatever we got and what we want. It's a slice. So we fix the test and the code as well. There is no error. Let's run the test. Okay. It got failed. It says invalid oplog, right? Why it is invalid oplog? Insertion operation. I'm just debugging the code. Okay. Oh, it is returning here error as well here, right? It should not. So instead of this invalid, it's returning nil, because if there is an error, I'm returning that error from here itself. So from here, it is just the success case. So I'm using Command Shift T to run the all the tests. This is the shortcut in VS Code, and now all the tests are passed, right? So with this refactor, where we change the return type of the generated skill, it is working fine. Now let's update our first story or the expected output of the first test case, because instead of just expecting this insert, we are expecting the create schema and the create table statement as well, right? So the create schema looks like this, and the create table is this. This is the expected output now. I have copy pasted this from the program statement, and if I run this, definitely it should be fail, right? So insert operation got failed because it is just returning the insert and not the create schema and the table. Cool. So test is failing with the right reason. Now we don't need to change. So insert this function. It returns the query as expected. Now before this, we need to generate these things. Generate the create schema first. So I'm just writing here create schema and create table. So these two things we need to generate here, right? So again, what is the schema? If you look at the oplog from the namespace, this first part is the schema and the second part is the table name, right? In case of the in case of the Postgres. So we need to generate this statement, right? So I'm just copy pasting again from here. So if I do this, where I'm just taking the first, splitting that namespace from the oplog and taking the first part and creating the schema. If I run this test, so it generates that SQL statement successfully. So create schema is there and insert query is there. Now let's generate the create table statement. So instead of adding the whole code here, so which makes this the parent function more complex. So I'm creating a separate function for this as well, where I'm just extracting it. So again, the shortcut for this, we can extract this code into the function by using Control T and extract the function. It generates this new function, and I can just rename it using F6, Shift F6, and say generate generate schema name, schema SQL. Right. And same, I will just copy pasting this one implemented function. Which is generate create table. So here we are generating the create table where I need the column names, and from that column names, I now need the data types as well, right? So from here, so this is again an implemented function where I'm getting the all the column names, and for each column name, uh, I'm getting the value of it, and I need the SQL data type for that particular column as per the value, right? But ultimately, it will be this. So this will generate the column name and the value. This separator is just for if the column name is first, then we don't need any separator. But from the next columns, we need comma as a separator and the space between them, right? And this is the ending statement where we are closing the bracket and semicolon, right? So how this get column looks like, I'm just again get column names. Putting that below this code. So get column names is again iterating the map from that log, getting a column name and appending that column, and again sorting that column name as per the order so that it will be the same order every time for the test. So we have this column names, and now we need to extract the SQL data types. So again, this SQL data type I have already implemented. This is similar to what we had here, right? We are getting the value, but here we need the data type. So if the value type is integer, then the SQL equivalent SQL type is the integer. If it's a float, 32 or 64, then it's a float. For Boolean, it's Boolean, and for default, I'm considering it's a varchar 255. So, okay, all the errors are gone, and this is our create table. So this is schema. I'm just calling this function generate create table. If I run this test again, okay, it got failed. Create schema is there. Create table. Okay, so the primary key is missing here, right? For ID, the primary, we are expecting ID as a primary key, but we are not identifying, or we didn't added the primary key as a word while generating this. So how to identify whether it's a primary key or not? So for now, what I can do, I will simply, so in the uplog, it's a underscore ID always, right? So this is the primary key for us. So what I will do, I will just pass that column name to this function, right? And I say instead of column name, call data type. Then if column name is equal to underscore id, then plus equal to primary key. And the space. Okay, so I'm simply checking if the column name is id, then append the primary key. Okay, so our test got passed. Okay, now just recapping what we did. We have initially we are generating single query for insert upload, but now we need to generate the create schema and the create table statement as well. So hence this generates query is no longer returning single string, but it's returning a slice. So we made the changes accordingly. We refactor that function and returning the signature for that. Also, we made the changes in the test because of that to pass the test cases basically. And then we wrote the two functions, one for creating the schema and one for creating the table. For table creation, we are extracting all the column names from the object from the upload, sorting them, and then extracting the data type from the value of those columns. So this is our story 4. I'm just committing it. Just remove this. We have implemented the schema and table creation along with the insert statement. Just comment. Okay. Now our next story. Create table with multiple uplog entries. Now, till now we have a single uplog, right? Where we are just parsing it and converting or creating the equivalent SQL statement. But in real, whenever we run this utility, we are getting the set of uploads continuously from the Mongo, whether it's coming from the running Mongo or from some file, but it is definitely, we are not getting a single upload at a time, but we are getting multiple uploads. So this story is for the same, where we are getting multiple uploads, right? And we need to generate the SQL statement for the same. Now, if you look at the upload, I hope this is white. I'm not sure whether it's visible. Let me just copy paste it here. Okay, so these two uploads are for the same namespace. It is for same collection. It is for test color schema and the collection name is student, where this is for, and the data is different. So that means there are two different documents which got added into that collection, into the student collection. And hence we need to generate the two insert statements for the inside this table, inside the students table, right? So now if you see our code, whatever code we have done, we are creating the schema and creating the table and then insert statement. If we pass these both the oplogs, it will generate the schema and the table for this oplog as well, right? Because it's a we didn't check whether that create schema or create table is already created or not, right? So every time for each and every oplog, it will generate create schema and create table, which is not correct. We are not expecting that. We are expecting this output where there will be only single create schema attachment and create table for that table, and then we will have the two separate insert into queries, right? So again, we are going to add the new test case for this, right? So just copy pasting that test case. So what are the steps we need to follow here? Basically, let me add that. So first, we need to handle the multi-oplogs as an input, because right now, if you look at this statement, this function, it is unmarshalling the oplog and expecting single oplog entry, right? But whenever we are getting the array of oplogs, then that is not going to work. So we need to handle that. Then we need to add the cache where we need to check if schema is already generated. So this create schema statement is already generated, then we don't need to generate that again. And same is for the create table, where if the create table statement is already generated, then we don't need to. We just need to generate the insert into statement, right? So I'm just adding the new test case where it is the again only insertion operation, but with the multiple oplogs. So I'm just putting this new test case with uh, multi-oplog, and the oplog is this. These are the two oplogs. And our expected output will be single create schema, single create table statement, but there will be two insert statements on this. So just closing this. Right. So this is our test. Now, if I run the test using Command Shift T, it gives an error saying cannot unmarshal because it's an array, right? So we need to change the again unmarshalling part where it is expected to be array. But if we change this as change this function as it is, then all the tests which we wrote, those are having single oplog, right? All these previous code oplogs are the single oplog. If we change this function as it is, then all the test case needs to be changed. So instead of that, what we can do, we will extract the or create a new function where let's say I'm just copy pasting this part, and so just for compiler I'm making it small. I'm trying to unmarshal this oplog as a single entry, right? If it works okay, that means it doesn't have any error, then it should call this function. generate SQL, and whatever oplog we are getting, like this. So we just, because we are already unmarshalling this part, right? So we don't need to unmarshal it again. And from here also, what we can do, just changing the data type as a oplog entry. Okay. So this is our existing code as it is. Still, it will fail because we are not handling the multiple oplogs, right? So if there is a error, so this will work for all the existing test cases, but it will fail if the oplog having the array. So if there is array, so instead of returning from here itself, what we will do, we will uh, try to unmarshal into the slice of array. So that means where oplog entries slice of oplog entry, right? And if it is also failing, that means it's a actual invalid oplog. So returning that from here. This is the entries, right? Now, but so I will just extract this outside and keep that single oplog entry inside, because if it is error and this is here, right? If it doesn't return an error, that means we need to just append that here. So at this location, for it is not a slice, so it will give a error. We are in coming inside here and we are trying to unmarshal that into the single oplog entry. If it gives a error, then it's an invalid oplog, but it didn't give the error, that means it's a single oplog. And what we did, we are just appending that oplog to this entries, right? And just remove that statement. Now in this oplog entries, we have a oplog, the object of the oplog entries, right? So I'm just ranging over it and oplog entry, just I'm just copy pasting this. Okay. So these are the oplog entries. I'm arranging on that and then passing that oplog, each oplog entry to this function, calling that function, and it will return the same SQL statement and appending those SQL statement here, right? So for each oplog, it will give me the related SQL statements, and I'm just creating a single slice of the SQL statement and appending that here and returning it. So if I run the test now, we are here. Right. So if you look at the uh, it is still creating the schema and the table, right? The, and it's the reason is we didn't add any cache, so we need to add the cache now, so that it will check whether the schema is already created or not and table is already created or not. So that what we will do,
So just to highlight, our current function already like creates the new schema and new table all the time. What we are
correct,
trying to do now is, if it is already created, somehow store that at some place, either global variable or some way store that somewhere. And if it's already created, then don't create it for the next insert oplog. That's the
correct.
idea, right?
Yeah. So here I am creating one cache as a map where map of string boolean, and this the key of in this map is simply the schema name and the table name. We can maintain two separate cache maybe, but so for one for the schema names, we will keep the track of all the schema names and save another cache for the or another map for the table names. But I we can still achieve that in a single map where for schema it is just the first part of the namespace, but for table we will add the schema dot the the whole namespace basically. So that way we can identify whether that schema or the table is created or already created or not. So I'm just passing that here. I need to keep that here because these are the multiple oplogs, right? And in this for loop, so this is the place where I know the state. And when I pass that map here, and it's a map of so before creating this create statement, I need to check if it is already created or not. And the simply we can do that like this. So we are splitting the namespace, getting the schema name and checking if the schema name is not present, not exist into the map, then generate the create schema. What is wrong with this? Okay. It's due to the extract feature. It unnecessarily. Right. Or simply we don't need to extract that again. We already splitting here. So let's use that. Schema name. Okay. So now we are checking this schema. Same thing. We need to check with the for the table. And instead of splitting, we can simply check into the cache where namespaces exist or not, because that is the whole uh, table name. And I'm just setting it true if it is not exist for this namespace. Okay, now let's run this test again. So it got passed. So that means this code. So we have just add the cache where it is checking the schema is present or not. If not, then create it, and same for the table. So this test is passing. This is all about story number 5, I guess. Yeah, right. So I'm just pasting that. Maybe multiple of input. This will generate these now. Create schema and table months only once. Okay, so let's move to the story 6. It's a alter table with the multiple upload entries. So what it says, the input of the story is very similar to story number 5, except in the second upload, there is a new field phone. Okay. And your job is to generate the alter table. So here in this upload, as it says, there is a extra column into the same collection, right? So we cannot just create the insert query because there is no phone number, right? So we need to obviously generate the alter table first, insert this column, and then generate the insert query. And the output will be looks like this, where it will add the phone number, and then the insert query will be like this. Okay. So again, is what.
So
what?
here, if we go back to the page, what we're trying to do is there is a, because Mongo documents are or can be different, there is no schema for Mongo as such for a collection. Two Mongo documents in the same collection can have different set of fields. So in this case,
Right.
the first document apparently had, let's say, 5 fields: ID, name, roll number, graduated, and date of birth. And sometime later, another document has extra field called phone number, which is a plain field. What we want to do is we want in the output, because we are creating relational database, it has a fixed structure. We've already created a table called create student, the test student table. We can't create another table with a completely new set of values, right? We kind of have to maintain the state and alter the existing table to add this new column, right? And then that's what we're trying to do in this story, that alter the existing table. So this is all about managing the state. We already have the state here in the cache. We want to find out if the schema now has changed, and if yes, what are the new additions? Maybe there are new subtractions. We can handle the subtractions in a way that we'll just set null values for all the tables. We'll not drop the column, for example. Right? If a particular value is missing, it will be set to null in the columns, in the poster assignment. Okay,
Right.
yeah, got it.
Yeah, so these are the basically steps we need to do where we, if the table is already created, and check if there is any new addition of the column from the upload. Uh, Add that table and column name into the cache. So how to identify that whether the column is already present or whatever create query we have generated, we need to again maintain the state. What are the columns we already captured, right? So we need to add that column name and table into the cache, and so that we can check if there is a new column added or not into the new this oblong. If the column is not present in the cache, then that means it's eligible for the alter table simply. So for example, and then if it is eligible for that alter table, then we need to prepare the alter table query first, and then the subsequent query will be the insert query, right? So let's start here. Now where as per the test, so right, just adding the test case first, where it says the alter table. I'm just copy pasting that. So yeah, this is the test where it is alter table with multiple oplog entries. This is the first oplog which will create the table with these columns, and this oplog, because the phone number is new, it should generate the alter query. So create schema, create table, then insert statement for that first oplog, then alter query, and then insert statement for the second oplog, including the phone number, right? Okay, I'm not running the test because it is definitely it will fail. Sorry. Okay. Now, so where while creating the table, as I said, we need to maintain check if that column is already present or not, and where we are generating that create query, create table query here, right? And we are inserting that or we are appending that query here, right? So this is the place where we know that this column is already captured. So let's add that into the cache. Right now, this table doesn't take any input as a cache. We need to pass that cache. Again, instead of creating a new cache, I'm using the same cache map here because it is not going to conflict with the table name or the schema name, because we are using the full string instead of just the single name for the as a key into this cache map. So here I'm just passing that cache map. Right, and I'm just adding this cache key here. So what I'm doing, I am using this namespace that is test.student in our case, right? So this is the key and dot the column name. So this becomes like this. So for each and every column, it will be for ID, the key will be this. For phone, it will be this, right? For name, it will generate the key like this. So it is different for each column. So we are creating that as a cache key and setting that into the cache as a true. Now, while creating the column, we mark those columns which is already created. Now, the next step is we need to check if the column is, or if this oplog is eligible for the alter table or not. And where is that place? If here, if you look at this, if the table is not created earlier, then we are creating the table basically, right? And if table is already created, then we need to check if the existing table is eligible for the alter table or not, right? So this is the place where we need to add the else if condition. Now again, I'm just adding this code where I'm checking is it is eligible for alter table or not. I'm passing that the oplog and then the cache, and then there will be a function called generate alter table SQL, which will return or append the SQL statement into the SQL array. So this eligible for alter table, the definition will be like this. So what it will do, it will iterate from the oplog again, check, create the cache key the same way we created into the create statement, right? And check if that is present into the map or not. If it is not present into that map, into the cache, then it is definitely a new column and is eligible for the alter table. So this is the simple logic for the checking the eligibility. And now we need to generate the alter table query itself. And this is the function where we are iterating through the all the fields, then getting the this is the value, getting the data type of that, again checking if the key is not present, right? So this oplog is the whole oplog entry, right? So we have all the columns there. Again, we need to check the into the cache where whatever columns are missing, we need to add those columns only. And it might be possible that we might have multiple columns at a time, multiple columns into the oplog which got added newly. So hence this separator as a comma, and it will generate the multiple add statements, right? And the end of the semicolon. That's it. So this is the alter table. So this checking eligibility and generating alter table, these are the independent. So for first oplog, what is the sequence of the flow, what is the flow? It will check if schema is not present, then it will generate the schema. Then first time it will check the namespace or the table is not present. So it will execute this part, right? And at the same time, it marks as a true. And inside this function, it will mark all the columns into that first oplog, and it's set to the true. And then it will generate the insert statement for the first oplog. Next time, it will see that this schema is already generated, so it is not going to generate. Uh, from here, it identifies that this table is already created, right? And then it will go to here. It will check the eligibility for the alteration, and then at this moment, as a second oplog, it has this phone number, so it will return true. And from here, we are generating that alter query, and next it will generate the insert query, including the phone number. So functionality wise, it looks good. Let's run the test. Yeah, so it is passing the test, including the alter table. I'm just commenting this.
I think feel free to interrupt and ask questions if you have.
Yeah.
This is a bit difficult.
Yeah, by the way, do you have any questions on the Slido, Chinna? Did you check that?
Yeah, most of them are addressed. Okay.
Okay. Okay. Okay, it's 7. So we can uh, we can take this story 7 as well. As per the plan, we plan only story number 4, 5, and 6. But I think we can cover this as well. So that way, in the next session, what we can do, we can spend more time on this story number 9, because story 8 is simply reading the uploads from the file, where it is just the way of getting the input to the tool. So we can skip that story. So this is the major one, the story number 9, where we are reading the uploads from the MongoDB. So where we will discuss more on the concurrency, how. So right now, whatever we have the code, it is the sequential data pipeline kind of, where it is just processing one upload at a time in a single routine. So definitely it is not the performant one. To improve the performance, we need to figure out, or we need to make the uh, orchestrate this core concurrency and process these oblogs concurrently, so that way it will be the it will process these oblogs fast. So for that we need more time into the session 3. So let's cover this story number 7. It is a bit complex one, by the way. It says it is handling the nested Mongo documents. As of now, whatever oblogs we have seen, it has just the column and the value with the different data types. But in this oblog, we have some columns, or we can say the nested document itself, because address having the array and phone number having the map, right? So this is the map of object, and this is just the map where we have the key and value for other values inside that. So as per this input, we cannot insert this address and the phone number into the as a column. Instead of that, what we need to do, we need to generate the separate tables for them, and these two tables should be associated with your original or the master table. So this is your master table, and the address and the phone will be your the client tables for the, or the associated table, uh, basically, with the original table. So expected out will be same, this creating schema, create table, student, then have the insert query. Then we need to generate the table. This is the associated table which I'm talking about, where in this table we should have the relationship as well, right, with the student table. So this will be the student underscore id as a reference key. We are not adding any constraint, it is just the logical constraint we will consider. And then the associated then the insert queries for that particular table, and same is applicable for the phone table, and the insert query for that particular phone number, where we will insert the student id as a so this will be kind of the relation between these two child tables with the parent table. Okay, let's I'm just in copy pasting the steps what we need to follow. So in the table creation now, if you look at the, let me copy paste that log. Let's open this. So as per this uplog, we don't consider these columns, or we need to skip these columns, these kind of columns where data type is not data type is slice or map, we need to skip into the create table definition, because this should not be part of creating the table called student or the master table, right? We just have these other columns whose data type is not slice or the map. So as far as now, right now, whatever create table function we have, it doesn't check anything like that, right? So I'm just adding the test case for the same, where for this story, yeah. So this is the insert operation for to handle the nested Mongo document. All right, and these are the expected statements. If I run this, right, so it fails with the right reason, because if you see the create table statement for the student, it includes the phone number. Uh, where is that? No. Yeah, so it includes the address and the phone number as a part of this, where because of the standard, the default data type, right? It says address is a varchar and phone number as a varchar. But we don't need this, right? We need to skip these two. So while creating the table schema, sorry, if value, the type of this value is slice or map, then just continue and ignore it. So this is okay for the create statement. It will not include that those two columns into the create statement, but we need to add this into the insert statement as well, because it is adding that those values for those columns as well here, right? So in an insert, so where I'm calling this insert, right? So now I'm skipping those type of columns from here. Let's now, if we look at the create table statement, there is no address and the phone number, and same is for the insert query, where we don't have those two columns, right? Okay, but now, so this is done for the creating the master table, but we need to fix the generating. We need to generate those associated table as well, right? So I'm just copy pasting the stuff for. Sorry. So this part, creating schema is fine, but creating table and creating the insert statement. So these two statements are applicable for both uh, master as well as the associated table, right? So this part we can extract into a single function, and then maybe that function can be a nested one. So I'm just copy pasting that implementation here. Instead of this, I will have this as a right? Generate create alter and insert SQL and namespace. I will just making this work, and we'll explain that code later. Okay. Step one, and this is the cache map. So that's stuff as well. This is a very big function because it's a complex one. And just cache map. So this needs a lot of refactoring.
I think maybe just as a session, if you want to go and show the other implementation, because I think we have to take a bit of time.
Yeah, right.
Just show the other implementation and sort of explain some parts of it. We don't need to walk through the entire code
Right. Let
because
me.
it's going to be super difficult.
Yeah, it is a complex one because it's a so nesting is not only applicable. So right now, as per the story, it is the only one level of nesting, right? But it might be possible that we can have a nested document inside this document as well, right? So the level of nested is the it can be a multi-level nesting object. So as per the implementation, if you look at this, we are same again. This caching part is forget about this. This is the cache where I'm checking the schema name is present or not. If it is not present, then create the schema. So this will generate the schema creation statement. And this part generate create alter and insert statement. It will be responsible for now generating the creating the table statement, checking if the table is eligible or not, the same way we had there, right? But here the extra stuff what we are doing, we are passing the foreign column as a parameter and check if it is not nil. That means it's a nested document basically. And if it is a nested, then adding that, this generating the insert statement for the master table. And the next part, it is for the generating the SQL statement for the nested object, where we are getting the column names, all the column names. And for slice or map, we need to generate the tables basically, right? If the data type is slice or the map. Now, what should be the name of that particular table? So here we are saying collection underscore the column name. So here the collection name is nothing but the table. So this is the collection is a NS part of one, right? And it's a student right now. So what is the foreign name table? It's a student dot the column name is address in case of address, right? So this is the foreign name table name. And now this is the new table, and in the oplog we don't have any key for this, right? For the master oplog we do have this underscore id as a primary key, so we do have the primary key. But for these associated tables we need to generate those keys our own. So we are creating this new column. This is the foreign column where as I said, it should be there should be a relation between the associated table and the master table, right? So this column is the column referring to that one. So collection name is again student. So what will be the name for this? It will be a student underscore ID. So this is the name. And what is the data? It's the ID inside that student table. So whatever insert query we are doing with this, so this is the ID into the student table. And this value is the reference key or value inside this newly added column as a foreign column, right? So this is that foreign table name and the foreign column. And now we are creating that.
Yeah, so I think the idea is that if you can you show the output SQL maybe once? In the test case maybe, the output, what it looks like.
Yeah, output, right.
Yeah, so what we want to do is, this is where we want to create a relational table. Like we want to create a relationship between two tables. Right, so the student table is the primary table or the main table, parent table. And we are going to have an address and a phone as two sub tables, which need to be related to the student table with some ID. And that ID is the student's underscore ID. That becomes like a foreign key relationship. We're not going to add a lot of, on the right side, if you scroll all the way to the right, we are not going to add of actual foreign key reference with FK and okay, this column actually refers to that with a foreign key and it has an index, etc. We're not going to do that because that will be again too much complication.
Yes.
but something that like that can also be done if we are interested. So,
So we are calling this nested function, where it will be, again, it needs to be, if it is a slice, and in case of a map, the table creation is same. So whatever table we are creating, that is fine, but we need to have multiple insert queries in case of it's a map. Sorry, in case of slice, if it is a slice, then we need to generate the multiple insert queries. And if it's a map, then there will be a single insert record. So if you look at this oplog here, if it is a slice, we need two records inserted into the address table, and there is a single record with the column personal and the work into that phone table. So hence, these are the two different handlings. If it's a slice, then for each column, we are calling this generate and create alter in insert SQL statement. Again, it has the cache, right? So it will not generate the create table and the create table statement, but it will just generate the insert query. So it will generate two insert queries for the address, and this will generate only one query for the phone. So this is the code for the same. One interesting part here is, now, as I said, we are generating here, it should have the primary key as well, right? Both address and the phone number, which is underscore ID, which is not there into the upload. We are generating that our own, like this. So if you look at the create table statement here, we are creating a new column called primary key. If the foreign column is dot name is not equal to null, so that means it is the nested column, nested table. And for nested table, we are creating that new column underscore ID. And the value is empty here, but while inserting, it must be UUID. Yeah, if you check, so while in the insert query statement, we are checking if underscore ID is exist or not. And definitely it is not exist for the nested tables. So we are generating that UID and assigning this generated UID to the underscore ID field. And the rest is the same. Yeah.
I think what I would say is that this is a bit difficult. So
Yeah.
what I would request everyone to, the solution for this is already available on the problem statement on Notion. If you want to take a look at that and study that on yourself, please do that. Next time
Actually,
we
what we can do, Chinmay. So next session it will be mostly focused on the concurrency only, where we will orchestrate the concurrency, and if required, then maybe we can have the session for the how to organize the code, basically code structure in a better. Right now we have everything into the main file, right? So how to organize this code
Correct.
into the separate structure, folder structure, and all. So if people are interested, then maybe we can take that as a separate session.
Yeah. Like for the next time, what we can even do is the solution that we already have. We can it is incremental in the sense that there is a commit for every
Correct.
story. We can go to the eighth story and do a diff between the ninth and the eighth story and kind of walk through that. Because writing live code for this much complex code becomes
Yeah.
kind of too much complex, and
Correct.
we struggle with very small code related issues, semicolons and whatnot.
Yeah.
So for the next session, we'll most likely take up a existing solution and show the diff and explain that, because in the Slido somebody also said that we should have more pros and cons discussion about the solution instead of directly implementing the solution.
Hmm.
So we can do that from the next time. Yeah, I think we'll leave it at that. I know today was a bit more dense in terms of code, and we were able to complete like 4 stories almost. As you see, as we go deep down this rabbit hole, the problem statement gets very, very difficult. There is a recursive implementation here for, or there is you saw the for loop, right? Where there are n number of addresses, then you have the same function gets called n number of times in a for loop, and there is associations and there's foreign keys and whatnot. It gets a bit tricky with respect to the actual domain. For the next time, though, we'll just take up a working solution and showcase and talk more about concurrency features of the programming. So the next session is where we'll really look at 2 types of implementation. One which we already have done, which is sequential, where there is literally no mention of any go routines, etc. So this program just runs, and it's a single threaded or single go routine kind of program. In the next session, we'll also try to make this parallel and concurrent in the sense that we can have multiple go routines separately, and we'll talk about how to orchestrate them. That's going to be the major purpose of the next session, where we'll also try to introduce something known as Handel's law, and like talk about why it is needed and how it can be applied in that case. So one request for everyone would be to please go through the existing implementation, kind of try to understand, prepare your questions, and we can sort of happy to answer them in the next session. All right.
Yeah.
Great. Thanks a lot, everyone. As always, we'll share the feedback form. We've tried to incorporate feedback from last time. If there is any new feedback, please share that. We'll also like to incorporate that in the next time. Thanks for joining.
Thank you.
All right. Thanks.